Myself Dr. Deepak. Today we will learn Coulomb's law. So what is Coulomb's law? Coulomb's law gives us a force acting between 2 point charges. These are 2 point charges and the net force acting between them is given by the force is divided by F. These are the 2 point charges A and B. It gives us a relationship between these point charges. Now, first of all, what are the point charges? When the distance between the two charges is significant in comparison to the size is negligible in comparison to the distance between them, then these charges are taken as the point charges and are marked as dots. So the force acting between the 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges, and this can be written as F is equal to K Q1 Q2 divided by R square. This is Coulomb's law. This relationship is the Coulomb's law. Now, what is the value of this K? K is equivalent to 9 into 10 to the power 9 Newton square by Coulomb square. This is the value of the K, and this can be also written as 1 by 4 pi E naught. So this is value of the K. Now suppose we take 2 point charges. These are at a distance R1 and R2 from the origin. Then force acting on these charges, this is the distance which is denoted by, this is first and this is second charge. Then this distance is denoted by R21. It is equal to R2 minus R1. So this one is Q1 charge, this is Q2 charge, and now force acting on Q2 charge due to Q1 is F21, and force acting on Q1 by Q2 is F12. These are the charges. So this can be written as, if we take F21, this can be written as 1 by 4 pi E naught Q1 Q2 divided by R21 का square, R21 square. Because force is a vector quantity, so this can be also written as Q2 R21 square R21. This is unit vector which denotes the direction in the vector, because force is a vector quantity. So this is F21 means force acting on charge Q2 by Q1, and force acting on charge Q1 by Q2, this can be written as F12 Q1 Q2 again R12 square unit vector. And this force acting on 2 this force acting on charge q2 by q1 is equal to force acting on charge 1 by q2, charge q1 by q2 with negative, which denotes the opposite direction. So this, you can also say, this agrees with the Newton's third law, which states that action and reaction are equal and opposite. Now, if these forces are repulsive, that opposite, then this can be written as, then force on q2 by q1 is in this direction, and the unit vector in this direction can be written as r. The force is along r21, and if this is in opposite direction, or we can say if they are not repulsive, they attract each other. These are the opposite charges. If q1 and q2 are the opposite charges, like one is plus and another is minus, then the force is towards each other. Then this force on side q2 by q1, F21, is along opposite to the opposite in direction, so minus sign r21, or it can be also written as r12 if they are opposite charges or they are attracting each other. Force now is in this direction, not in this direction. Now coming to force, up to now we have seen the force acting between 2 point charges. Now we will see force when charges are multiple. Point charges are multiple. Like suppose we take 3 charges, q1, q2 and q3. This is the origin, this is the position vector r2, this r1 for charge q2, r2 for charge q3, r3. Now this is r12, force acting on 1, and by q3 to on q1 is r13. So the force acting between them is simply vector addition of the force acting over the individual charges. Like if the force acting on q1 by q2, then force acting by q3 on q1, they are just added upon. Like the equation becomes now 1 by 4 pi f e naught q1 q2 by r12 square r12 unit vector plus q1 q3 force acting on q1 by q3 r13 square unit vector r13. This will be the net force acting when charges are multiple. So if you like my video, please subscribe and like my channel. Thank you.